It's a pleasure for me to share my experience today. I was thinking it will be a class with young students, but I see there is a lot of people with experience. So I prepare my presentation for young people. My goal today, I will not be so technical, but it's to give you tracks to think about. Don't forget something. It's really the goal of my presentation. I have done a lot of mistakes in my career, and my colleagues too. We learn a lot about this mistake, and the goal for me is that you will not do the same mistake as us. I have to apologize for my English, and it's only my third language. I speak French, German, English, and Italian, perhaps in some years Castellano. But I think you will understand. I will take time to let the translator react. I hope they will do a good job. Okay, it's okay for you, the translation? Okay. So that's the scope of my presentation. I will speak first for logistics, for simple and short tunnel. I hope it's known by all of you. Then I will make the comparison with complex tunnel system. And I will speak about a lot of points in complex system. I will see if I will take question or not. I will begin with something that I do very often in Lausanne. It's make a small brainstorming at the beginning. And the first question to me is, what has influence on tunnel logistics? What can influence tunnel? Here you have two pictures with one jumbo and one TBM. And there is other things that influence logistics. What are you thinking about what could influence the logistics of an alpine project? There is no bad ideas? Nothing will speak. Yes?
High altitude.
High altitude, yes. You're right. Yes, exactly. That's the goal today. The length, yes. Other ideas? The geology? Yes, exactly. You are right. Tunnel length, topography. I think, for example, space for installation. That's very important in mountainous regions. Accessibility to the overburden. Geology. What is very important in geology is uncertainty. That's a very important point when you are managing long and deep project. Hydrogeology, that's very important. In hydrogeology, there is the uncertainty is bigger than in geology. Then you have also the tunnel system. Are you planning a railway tunnel or a road tunnel? What will be the size of the gallery? Is a small tunnel, is a big tunnel, and the complexity of the system. That's very important in long projects. That's a key point in very long project. But there is other things. What do you think? What can influence? Is related to people. No ideas?
Knowledge.
Knowledge, for example, yes. Knowledge, safety, yes. There is decision of the clients. What is the client? For example, in the IT groups I lead, there is a Chinese woman, which is member of the board of the IT. And for the Chinese, what is important is to go fast, to do the tunnel as fast as possible. What is the project duration? Has the client time or not? You want to have it in operation as soon as possible or not? Is the client ready to accept risk? That's also very important. And the risk sharing between the contractor and the client is a very important topic in tunnel management. Another point is the repartition of working load. If there is a big tunnel, what's the client to have? Only one contractor or more? And the project duration and also the geology can influence also the number of loads. Another point, I don't know the regulations, the legislation in Argentina, but it could have a big influence of your project. Politics, for example, there is a big project in Europe that's Lyon-Torino between France and Italy. And this project is blocked for years, and it's take perhaps now 20 years, because the population of the Italian region was not prepared for the projects. And that's very interesting, because there is two big projects, one between France and Italy, and one between northern Italy and Austria. That's Brenner. And the Brenner people of the South region, the Italian regions, are German people, I have to say, Austrian. They want to have this project. And the project is going very well, and the other project between France and Italy is completely blocked because the population is not ready. There is, I have to say, eco-terrorism against the project. Another point is the contractors. As the contractor experience, as the construction machine to do the job, is ready to build new machine, and what is the excavation methods? It could also have a big influence on the logistic. Okay, I hope you know this excavation cycle. The normal excavation cycle is previous. This picture is previous for students, but it's always the standard cycle of drilling, charging, ignition, and explosion, ventilation, scaling, and mucking. And what is very interesting here is here, between scaling and mucking. For this picture, for example, the scaling comes before the mucking, but very often, if you are in a good geology, the contractor prefers to do the mucking and can do the mucking before the scaling. Then you install anchors and support shotcut. I hope you know that. And for the logistics of tunnel, you need a simple equipment. You need jumbos or road leader. If you're in a not so good geology, you can also use road leaders. You need wheel loader. You need excavator here. You need robot for spread concrete, dumpers. You need some transport truck to bring, so for example, the anchor on site. And you need personal buses. It's all. And you can begin your tunnel with that. I think it's not so complicated. But there is, I think, a very important thing in the logistic of a simple conventional tunnel, blasted tunnel. That's the mucking procedure. It could, I have to say, the advancement speed, the velocity is very depending on that, on the mucking procedure. In your picture, you can see that you have a normal loader, and there is a bay, a niches to charge the dumpers. It's very often that's a choice of the contractor, the distance between the loading bays, or how the truck will be parked in the loading bay. But if you want to go fast, there is, in my opinion, one big solution is to be parallel between to go parallel between the loader and the truck, and that's a very common mistakes of clients. For example, access gallery, they think we will do the gallery as small as possible to spare money. It's a classical mistake. If you have to plan big tunnels, if you have to plan access gallery, make it so large as possible. I think, in my opinion, 50 square meters is the minimal size for an access gallery. 70 square meter is the optimal size. And with such loader, wheel loader with side dumping, you will go faster. The rest of logistic, you have a very interesting picture of the beginning of the Jornadas project. You have some equipment, you need power, you need electricity. Don't forget that. To begin a project, sometimes it takes months or years to get the electricity on site. You need also industrial water, clear? Very often in Europe, I have to say, electricity supply and water are installed by the clients before the construction. That's the job of the clients, and after the constructor comes. But it's usual in Europe. We cannot say it's usual in the rest of the world. Then the contractor has to install ventilation, compressor. You have to manage the muck, so you have to find a place for deposit. And I have to say, deposit is the thing who stays after the construction. So the management of deposit is also very important. You have to be a workshop, you have to have office, change house, you have to have a batching plant, very important thing, wastewater treatment, you have to have explosive and a separate detonator stocks, you have to park the engines, you have to stock the material, so you need place. It's difficult to say what is the minimal place to do a tunnel. For me, under 10,000 square meters, it's difficult to have an optimal place, but it's depending of the site. It's difficult. Here you can see, it's the beginning of the project. We are in a small valley, we have not a lot of place, and we began the project in a very small place. Here, if you are lost in the mountains or in an isolated regions, you have to be a camp with restaurant, with dormitory, with toilets, and shower for the people. It could take a lot of place to install that. In Europe, for example, every worker has its own, all the rooms. So the big advantage of conventional tunnel is that you can begin the tunnel from a very small place. And you can extend the place by using the excavation material. That's a big advantage. If you begin with a tunnel bore machine, I will show some example, it's not the same. And it's the same place 1 year after. And don't forget that if you are working in mountainous regions, you need to be ready for winter condition. I think if you are working in the Salta province, it's not the same that in Patagonia, but if you work in the south of Argentina, I hope you need to be ready for winter conditions. So you have to have isolation of your installation. For all the water ducts have to be isolated or heated. And if there is snow, the engines and tracks have to be equipped with winter tires and chain wheels. It seems to be normal, but a lot of people are forgetting that. And very important for the place is the management of the water, of the wastewater. I have to say, in hydrogeology, there is a lot of uncertainty. You should to know that. And you have to manage the water, and you have to treat the water according to the regulation. I don't know the regulation in Argentina. I have to say in Europe, there is very strong. And you can see water coming from the tunnels, and the result after that. And you need sometimes more than 5,000 square meters to manage the water. And the problem at the beginning, you don't know exactly the quantity of water you will have. So you have to plan it with the possibility to extend the system. Okay, now I come to the third part of my presentation. I come to the problem of long tunnel. The problem of long tunnel is very simple. The planification, I have to say, the design influence the logistic, and the logistic influence the design. And then it's an iterative process. Here you have the example of the Lötschberg. We call this drawing the spaghetti drawing. That's all the variant we have done for the Lötschberg. Some of them are coming from political reasons. Some of them are coming from geology. I think I designed perhaps 30 of this variant. It's very complicated. But to do that, it takes time. It's not done in 1 year. Alors, if you are planning long tunnels, the first things to do is to search for good working sites. You need place to install your portals with working size, and if the tunnel is long, you need lateral adits, you need access gallery or shafts. And here you can see that's for the Lötschberg, that's only 4 opportunities in the region. There is here, I think between there and there is perhaps 40, 50 kilometers. There is only, in this mountainous region, only 4 good opportunity to install working size for an adit. It's not, that's really the first things to do. As teacher in Lausanne, I do some exercise in a project between Switzerland and Italy with the students. I have to say there is also 4 or 5 places available, I have to say. So it's very important in each site to identify the hazards. The natural hazards and the other problem, for example, the accessibility. And you also look for power supply, and you have to also to look for the muck deposit. And if there is, if it's a lateral adit, the problem of altitude is very important because it will influence the length of the shaft or the length of the galleries. An example of accessibility here is the transport of TBM part on a mountain road. I have to say it's a very good road. The weight of the TBM part is 150 tons. So to come from the valley to the working sites, it takes 1.5 years. Life days, sorry, 1.5 days to come on site with a problem in each curves. And that's a very large road, and it's perhaps 8 meters. But you have to think about. Another problem when you are working in the mountains is the situation in spring times. Because sometimes the soil is frozen in winter, and then in springtime you have very often breaks of your road, and that's an example we had at Jornadas. There's a lot of holes in the roads were completely destroyed. So we had to stop the work for 3 weeks to build a new pavement in concrete. And if you have some roads, sometimes I have to say it's better to do it directly in concrete, to do it with to prepare a good road and to prepare the road before the construction. Here it was an existing road. We used it. After 2 years, the road was completely destroyed. In some region, it could be interesting to access with cable cars. It's very frequent on hydropower projects to access with cable cars. For example, it was previous at the beginning of Jornadas to access with cable cars. The problem you have if you choose this solution, all the logistics have to be adapted to the cable cars. So you have to have a big installation place, install all the equipment in container, because there is a weight limitation of the cable car. So if you are planning the cable cars, you have to know the weight of the mechanical parts, and as you have to discuss with the contractor, or is that the question? Should the client install the cable car before or not? In the example here, that's a project in Switzerland, a hydropower project Lintal. The client installed the cable cars before and wanted to to manage them. And after perhaps 4 years of projects, they changed the management of the cable car well done by the contractor, because there is a lot of claims about the cable cars. If possible, don't use cable cars, but sometimes it's only one opportunity to access on site. Another example, that's my project, Jornadas. We have a lot of, the big problem we don't have enough space in the valley to install all our equipment. So you have to manage on a long chain. You can see that here, here in orange, that's the installations place, the working site here. In green, that's the muck deposit. We have 2 definitive muck deposit and 1 provisory muck deposit, for example. And we have to manage that. And for example, to have concrete granulate here, the rock is taken in the mountains, sometimes go up, is stocked here, after go down, is crushed here, go down with a bank conveyor, is charged on a truck, is crushed here, and come back as granulate for concrete here with trucks, with band, with trucks to be used. It's a big problem, and the logistics should be very good studied in advance. The space for the installation, I say for me the minimal, I say to you the minimal place, but in fact you have to adapt yourself to the situation. So an example here is always Jornadas. We have here 2 power plants, 2 existing power plants, and here we have our muck deposit. So we have our installation site here. The camp for the worker is here. There is here place for 600 people, a restaurant and dormitory for 400. And the other comes with trucks. We have the office here, so we adapt ourselves to the situation. But you can see here there is no space. And to access to here, we built a new tunnel through these small mountains to go only to access to the site. I have to say, sometimes the best solution is to adapt to the topographic, and it's always possible to extend the place with muck material, and you can use, there is a lot of reinforcement system to extend your place with temporary walls. Here you can see that, to extend your place. You have to be good geonautical engineer and a good contractor, and you can extend your place. One of the problems we have hit, for example, is also the problem, ecological problem. We cannot use all the space due to ecological reasons. If you want to use TBM, TBM, if you have a very, very beautiful hard rock TBM, if you want to have TBM, you should think first to the space and to the power supply. For example, this machine, you need 4 megawatt. Before you, is the same machine this machine was used at the Lötschberg in 2000 and 2002, and 10 years after, between 2010 and 2012, the machine was reused for Jornadas. But for using the machine in both cases, we have to discuss with the electricity company before the project, 1-2 years before the project, to install new electrical lines to have enough power for the project. And you cannot say, I will take a TBM. If you think, I will use a TBM, I have to install the power before. That's a very big problem sometimes. And in one of the audits of the Lötschberg, we decided to don't use a TBM due to the electrical problem, the difficulty to install a new electrical lines in the valley. And another problem is to have space. For example, this machine is 142 meters long. So you have place to construct the machine on site. And here is at a relatively good site. We can build the whole machine. And here, we don't have the space. We have only 30 meters to build the machine. So we blast 100, 120 meters before to install the machine. And here, all the trailers. Here you have, in this machine, you have 6 trailers. That's the TBM, and the rest are the trailers. And the TBM and the trailer, as the first trailer, were mounted on site, and the other were mounted on the site and moved with the crane. You have to have imagination to find solution. As I said, the design of alarm tunnels is an iterative, complex iterative process. At the beginning of the studies, for the feasibility studies, you can work, I hope you can work with the existing geological document and surface observation to make the first variant drawing, to do that. After to have the first variant, you had to begin with the geological exploratory boring. And after that, we will have the result of the borings. You will have a new interpretation of the geology, and you will probably change the project and make new boring and change the project. It sometimes can take a year to do that. And it could be repeated several times. I will show you some example of that. And for that reason, it could be very interesting to initiate access gallery, if you have a long tunnel system, to create edits before the construction of the main project and use the access gallery for exploratory purpose. So we have more details on the geology of the rock mechanics, and you will probably gain time on the project schedule. But it's a client decision, and such client decision could have a very important impact on the project design, and on the tunnel construction, and on the tunnel logistics. First impact, so you will have not only one contractor, but several. And after that, you have to manage the different contractors. But with that, you can optimize the final design of the main tunnel. And you can take in account the geological, the geomechanical observation made in the access galleries. But to do that, so you have to prepare in advance the areas, sometimes the logistical caverns, and for that, I have to say, the client's engineer should have experience on logistics. Sometimes it could be wise to speak with some contractors before, ask the contractor what will be the site, what you need for such cavern, to discuss with the contractor, if you are client's engineer or client, to have an idea what to plan. I do this job one time for the Tunelería-based tunnel in Switzerland. So the client's engineer who was chosen for the project had no ideas in the logistics. So I was advisor of these people. And that's very important because we develop a system of caverns, and no, this contractor were at the Brenner source part. And I was in Italy at the Brenner, and I saw the cavern. It was exactly what I managed, what I designed at the Tunelería, a little bit bigger because they have new experiences. But you have to have experience to do that. That's very interesting to do such job. But the people who have experience are the contractor, so the client engineer have to speak before with the contractor. I have to say how many time I have. Sorry. Okay, I think I'm on time. I will show you another example of the Lötschberg. It's depending of politics. I think it's the same in South America. It takes time to prepare big project. Here, that's really the design phase of the Lötschberg between construction. It take us 10 years. We take, I think, 3 years to make the the preliminary design and really the studies. And after we had the public inquiry, it take us 2 years, but it have to be how to say, decaled. It will be done in different regions, not at the same times. And that's a big influence of the project. And the tendering of some working loads were done when the other were only on design, on design stage. Sometimes it's difficult to understand that, but it's the north part of the Lötschberg, I have to say, the design was clear, and in the south part, we have a lot of political problem and financial problem, and we have to move forward the decision. And during this time, we make some exploratory galleries with a TBM to be sure that the design is okay or not. So it takes time. I say it takes sometimes. Perhaps it's an extreme case, but it takes 10 years only to design the project before construction. And so it's very interesting in that period to perform audits, and the audits have, I have to say, 3 functions. During the design times is reconnaissance of ground condition or geology. During the construction time, the functions is access to the tunnel, and they are used for the logistic. And during operation, you can use it to access for the maintenance. You can use it as escape route if you have, for example, a brand in the tunnel, access for the rescue time, and you can use it exactly for ventilation purpose, and if there is a brand, for smoke extraction. Another example for the Lötschberg, here you have one exploratory galleries performed with a TBM, drive with a TBM, one access adit, and it's a descending access adits. They were drive before the main project. Another descending adits we was begin some years after, but also before the beginning of the project. That's a 4-kilometer adits, descending adits, and another small galleries to control a difficult geological zone. And after that, we use these 2 adits to install multifunctional railway station. These stations are previous for safety and maintenance. The tunnel is 35-kilometer length, but the length of all the galleries is 80 kilometers. 88 kilometers. So it's very long, and so we use this access gallery to install safety station. In this station, we can stop a train. If there is a big problem with the train, if there is a brand in the train, we can stop the train, evacuate people from the train. And here there is a little bit complicated to explain for me in English, but for political reason, we use this exploratory gallery afterwards as safety galleries, and one part of the tunnel is not constructed. But it's really a false political decision. And all these points at the bottom of the adits are the center point of the logistic, are the logistical basis of the tunnel loads. And after the construction of the adits, there were only 3 main loads, and the construction of these tunnel loads were performed from the adits, not from the portal. And here also, the loads were done from the adits, and only the south part were drive from the portals. So I will speak yet about this point, this portal, for example. There was the only one point on the south of the Lötschberg, of the south Alps in this region, to install a working site. And I have to say, we have to look for the advantage of each site. And here, the main advantage of the site was the access. It was very close to the existing railway tunnels, so we can have a good railway connection. We have not a lot of space. There is I don't know if there is 10,000 square meters, and you can see all the installations are protected against winter conditions. Here, this part against avalanches, but we have a connection. For example, here all the mucking went away with trains. It was the solution we was choose. That was really the advantage of the place. This place had a lot of disadvantages. I will speak about this after, or in another. And it's always ways, if there is a great geological uncertainty, to begin the adits early. And so you can adjust the latest alignment of the main tunnel. You will gain a lot of information by driving adits in the mountains. And if possible, the route of the adit should be parallel to the main tunnel. The orientation of the layers, the orientation of the discontinuity has a big importance of the geomechanical comportment of the tunnel. So if you are parallel to the previous tunnel, you will learn a lot. And you can also use your adit and to change direction, to perform perpendicular galleries, to see how is the comportment of the rocks in other directions. So you will learn a lot about geomechanical properties. And one of the advantages of the adits is always to go at the key point of the difficult geological point. So if you have fault zone, for example, it could be very interesting to go very close to the fault zone. It will allow you to treat the zone because beginning the main work. And the goal, it's always an optimization. So with performing adits before, you can optimize the main project, get synergy, and at the end, the goal is to save money. And by performing adits before, by performing reconnaissance galleries, you can probably save money. It's not evident for all clients, because at the beginning of the project, the client said, why should I pay for exploratory for exploratory boring? But by experience, at the end of the project, we will say, if we have know that before we have changed it, it's very common that during the project you are thinking, it was better if I had performed these galleries. Another example of the Lötschberg. So we have made exploration tunnels some years before the main work, and we have also prepare adits before the main work. In red, that's the main excavation. And don't forget that after the excavation, there is a concreting to perform, and there is also the installation of the electromechanical equipment. And my experience now, it takes years to install the electromechanical equipment. Think at that from the beginning of the project. Okay. I will show you an example, that example, what is the interaction between adits and between access galleries and geology. That was this problem we had at the Lötschberg. We have a layer with high water pressure, and we know that the layer was in connection with thermal springs, very, very important thermal springs. So we have to protect this thermal spring. And the water was previous here at the connection between the yellow and the blue layer, exactly here. And so we go with our adit of Verden in this zone. We arrive here with the adits, and we begin some galleries, and we perform some exploratory boring. And we have one surprise. Here, we are, the overburden in that zone is 1,500 meters, and we are surprised there is not only one zone but two. This one was previous, but there was another zone with water, and we are not allowed to decrease the water pressure. We have to maintain the water pressure, so we have to inject the zone, the both zone, before to drive the tunnel, and it takes us more than 6 months to inject the zone before digging the tunnel, before boring the tunnel through this zone. So if you have such problem, it's wise to do that in advance. If you don't do that in advance, you will lose sometimes months or years by doing injection. And the problem we have in this zone, there is a multifunctional railway station with a safety zone where we can stop a train and with changing lines. So we had to adapt the project. I think we move the position of both elements 5 times during the project, and the design, final design can only be performed when we have drive through the tunnel, when we were sure where is the position of this zone, these layers. And we decide to separate the station in 2 parts, the safety station, and here the changing of lines. And here you can see there is some caverns. These 3 caverns here are for logistic purpose of the contractor. This cavern here is a ventilation station for the exploitation, for example. And we try to use the synergy between construction and excavation. And you can see the same small 3D models from the zone. Here you have the railway station. In blue there is a smoke extraction system if there is a brand in the tunnel, so we can stop a train here. That's the caverns, the 3 caverns for logistic. All the yellow parts here are for logistical purpose here. Here you have the changing of line with 2 caverns for the electromechanical equipment, and I have to say the fault zone, that's not exactly a fault, but the zone with the water is in between. And so we have to adapt our project to the geology. And I have to say the primary objective of an adit is to reduce the overall construction time. It's the duration of the work. And the main function of the adit is to join the tunnel at an intermediate point in order to enable work to proceed from that point. And sometimes it's for safety or logistics reasons, it's also necessary to reduce the distance between the working files. And this one, the distance from the working files to the portal should be decided by the client. The reason of that safety, transport time, ventilation. If the tunnel is too long, it would be difficult to have a good ventilation of the working files. And sometimes also, if your portals, it could be the case, are located in city, it's not possible to perform a so big tunnel from city. We have one case in Switzerland, that's the Tunelería, with the tunnel is 19 kilometers long, and all the excavation is done from the middle of the tunnel. Both portals are in cities. And here you can see the example here of the Lötschberg. The blue lines are TBM excavation, and the green line are conventional excavation, drill and blast. And so we had 10 tunnel drives, and the goal was reduction of the time of the construction and the risk management. And for example, for my Chinese colleague, the maximal length between the portal and the tunnel is 5 kilometers because they want to go fast. If I take the example of the Gotha, the distance, the maximal distance is 14 kilometers. In the Brenner, what is that? with a little bit more. Huh? So it's also a client decision. It's influenced by the topography, but the positioning of the site. Huh? But the client have to think on that from the beginning of the tunnel. If you want to decide to fix a maximal length or not. But if you have tunnels from 20, 25 kilometers, you have big logistical problems, huh? And you have always safety problem. You have always to think how I will evacuate somebody with hurt. Or, if you have an accident, it's need time to evacuate people. And the ventilation is a very big problem too. The design of the adits are very important. In the ITR Working Group 17, we write a report only on these things, on design of adits, huh? Because they should fulfill several functions: transport of equipment and personnel, evacuation of the muck, the haulage. You have to supply materials, you have to evacuate clean and dirty water, you have to bring industrial water, and you have to evacuate wastewater. You have to manage the ventilation. Huh? You have to bring power, electricity. Very important in its communication, safety, and if necessary, cooling. Huh? If you are at 1,000 meters under the surface, the temperature of the rock will be relatively high. Huh? So you have, I will come on that point, you have to cool your tunnel to work. Huh? In some country, sometimes the legislation will okay. Sometimes it will impose the two access. That's very special, but it's sometimes you have this problem. Huh? You have to build two parallel galleries. I don't know that, but for example, at the Gotthard base tunnel, they perform one shaft, and after some time, they realize that the shaft was too small to use it for the lift and for the ventilation, and they decide to build another shaft only for ventilation. Then sometimes you should have two parallel access on one point. Huh? Sometimes it's imposed by the safety regulation. And you have to, when you are designing an adit, you have to plan all the equipment who could be installed in this adits. Huh? And I have a good example of France. So the design of an adit is very big. I think it's more than, say, 70 square meters. So the adit was previous to cross with two trucks. There is a way for the pedestrian. There is a place for the band conveyors. And there is the ducts for water, for pumping and for fresh water. And there is a ducts for ventilation. And it takes place. I know some project in Switzerland where the client said, I want not to be adits bigger than 25 square meters. And it's not possible to construct big project with so small adits. I have to say, for long project, the use of conveyor is highly recommended. The advantage of using conveyors, it reduces the ventilation. Here you have this example of Verden. The inclination of the galleries is 12%. If you have to let go trucks go up with the muck, the ventilation will be not possible. And for inclined access gallery, there is very important to use conveyors to manage to do the haulage, to manage the muck, to take the muck away. It's really a good solution. And in this project, I have no picture, but the conveyor belt were installed very close to the front. There is a distance, I think, from 200 meters between the conveyor at the excavation phase, and the conveyor was suspended on a platform, and directly 200 meters from the front, there is a crusher, a mobile crusher, and the rock is taken back with machines, with loaders, directly in the conveyor, crush on site in the tunnel, and directly take away by the conveyor. It's a very efficient solution. With such solution, we will go faster. Sometimes they blast more than 3 times in a day. Sometimes they blast 4 times in a day with such system. That's really the fastest system for a tunnel, for driving a tunnel, to have really an industrial system for haulage, for excavation of the MIC. But if you are planning such man conveyor, you should think about the radius of the galleries. You have to speak before with producer of conveyor to be sure to have enough space for curve. You should know the minimal radius of such band conveyors. That's very important. In another example, accessing that's another trans. So the main access galleries was drive with a TBM. That's a TBM drive. Here you can see you have exactly the conveyor. The muck is directly from the cutter head of the TBM charged on the conveyors, and it's sent away by the conveyor. You have the ventilation duct, you have the water, the power, and after we have to build a road on the tunnel, and that's a problem when we are using TBM. And the goal was to build the road directly under the machine, but it was not possible. I think the contractor don't manage that so very efficiently, and the road was performed afterwards. So you have a drainage. First you have a drainage, and you have to bring back muck and to create your road, and you have a concrete plate to drive heavy trucks. And at other point, you have to have caverns. You have to have caverns for the logistic. It's such point at the bottom point of the adits. Here in this cavern, an example, you have a batching plant for producing the concrete. Here, that's a very special case if you have a mechanical workshop in the tunnel, because the distance between the portal and the key point of the tunnel, the center point of the logistic, is so long, so the contractor decides to excavate a cavern to a mechanical workshop. The advantage of that is you don't have to take away all the machine to be released, to be controlled. A question we have very often, it is better to have a descending galleries or a vertical shaft. And I have to say it. Firstly, you should consider the possibility as to have an access gallery where you can arrive with your trucks. If you have vertical shaft, you have exactly the same problem with cable car. All the system is depending of the logistic. All the logistic have to be adapted to the shaft. And consider the shaft only where there is no other solution. Very often we consider shaft in Europe for ventilation, small shaft for ventilation, but to access is really a bad solution. And you have always the option, but I think the main option is an descending galleries. And what is the optimal slope of the gallery? I will say 12% is the maximum. We discuss a lot in the group. What is the maximal? Some people say 8. I say 12. But you should know. I don't know how are the trucks in Argentina. If you decide to plan to design such a gallery, you have to perhaps make some discussion with the contractors, because we had the problem now, for example, for delivering materials, 12% is very extreme, I have to say. But don't go over 12%. But the galleries have many advantages. First advantage is safety. The fireman, the ambulance can come direct on site. For the haulage, there is no interruption on the logistical chain, and you have no risk of falling material in the shaft. The excavation of the gallery is faster than the shaft. You can use the normal tunneling equipment, and the management and water is simplified. In some cases, it is better to perform a shaft if you have vertical geological structure. If you have very good vertical structure, that's one. We have this case at the Cedron shaft. It's at the Gotthard. It's better to perform the shaft because there is one vertical layer, very good. So they perform the shaft in this layer. If you need to reduce the excavation volume, if you have not enough space to create deposit outside, it could be a solution, and for ventilation. But don't forget that the excavation of shaft is very slow, very slow. If you make such shaft of the surface, you won't go faster than 1 to 2 meters per day, because you need a lot of energy to bring back the muck. One of the good solutions to perform ventilation shaft is to make it by raise boring, or a combination between raise boring and enlargement by drill and blast. But for that, you need to have an access to the bottom. So that's clear. You cannot perform raise boring without a cavern on the bottom of the shaft. Here you can see a typical equipment. I have in my career work on two sites where we had shafts, and in both projects we have do it with first excavation with raise drilling and then enlargement with drill and blast. Here you can see such equipment. Here you have the hole of the first hole performed by the raise boring, and you have here the excavation, the jumbos for the blasting. And here you have exactly the same equipment here in another shaft for the blasting. These are really a common solution. And here that's exactly the equipment for Jornadas project. So it's this big mining equipment to be installed. So the height of the cavern here is 18 meters. So if you want to have a shaft, you have to plan that in advance and discuss with the contractor how big should be the caverns. Here you have the working platform. And after that, it could be, when you are enlarging the shaft by drill and blast, you can install your protection, you can install your anchors, the sprayed concrete, and for Jornadas, we have to concrete it for the water, so we have a sliding formwork to do that. I will present that tomorrow. Whatever the solution you choose for your edits, for inclined gallery or a vertical shaft, a very important thing is the water management. It's essential for the success of the project. The problem with the water, you don't know exactly the quantity in advance. If you are not ready to manage big water incomes, you will be very quickly a lake on your gallery or in your shaft, and you have to pump it, and it takes sometimes days to pump the water. If possible, we avoid to drive descending galleries, but for such long tunnel, you have to do it to access. But if you have descending galleries, you have to manage the water. You have to be ready to pump a big amount of water. And that's a problem that the geologists have a lot of difficulty to predict exactly the amount of water. So you have to have enough power supply, enough pump on site to cope with unplanned water inflow. And if you are performing vertical shaft, you have to seal around the shaft in advance, because it's not very interesting to work under a shower, I have to say. The efficiency of the work, if the people are working under a shower, is not good. Very often there is a rule to say more than 1 liter per second in the shaft is too much. So if you are performing a shaft, you have to inject before the excavation. Before the excavation, you can perhaps excavate 50 meters, stop, inject, before the next 50 meters to manage the water. Another important point on such complex tunnel system is the ventilation. One of the problems, if you have several portals, you have a complex tunnel system, and there is difference in elevation. It will be very complicated to manage the ventilation. So you have to plan the ventilation in advance, and you have to be ready to adapt, to manage the ventilation from a central ventilation station. At the distance of elevation of the portal, there will be a natural ventilation, and sometimes it will be better to go against the natural ventilation to manage your system. For example, you will have fog in tunnel due to difference in elevation if you let the natural ventilation go. Will be a problem of safety because you have fog in your tunnel. If you have railway tunnel, twin tunnels, it's very interesting because you can use one of the tube for the ventilation of the other. What you can do is to bring fresh air from one side, have ventilators in the connection galleries, and use the other side as evacuation galleries. Both of the face are ventilated with fresh air, and you need lockers here to go from one tunnel to the other, and it's very important in such case to manage the lockers. To know they have to be only open to go through, and they have to be controlled by the ventilation station. If there is somewhere an open door, the system don't run as previous. But if the system is properly managed, it's a very good solution. And with such solution, you can begin to concrete here, because you don't have the big ventilation duct. It's a very, very good system. You can also use shaft for the ventilation of your tunnel. If you have an intermediate shaft, ventilation shaft, you can have fresh air in your tunnels, and here begin with the concreting of your tunnels. That's a solution. It costs something, as you will be some problem. For example, if you come with fresh air in the shaft, in high mountain in winter, you will have ice. Sometimes it's wise to have another system, so to evacuate. I think it's better to evacuate the polluted air through the shaft. If you are in high mountain, you will be confronted with winter temperature, negative temperature, and that's a picture of my project. That's our ventilation station during the first winter. After the first winter, we decide to heat the air ahead the ventilation station. So we have some installation, some heating installation before the ventilation station to have 3 centigrade grade to avoid to have ice, because we had ice on 4 kilometers of gallery due to the winter temperature. And in other case, you have exactly the contrary. If you are working in a tunnel with more than 1,000, I think 1,000 meter overburden, you will need to cool the working site, the working place, cool the front of the tunnel where people are working. So you have to exchanger between water and air, and you have to evacuate the water, to have to bring fresh water and evacuate hot water. And for that, you have to have exchanger. Here you have exactly such flying platform. In the platform, you have the installation for the band conveyor, and you have the air exchanger. And for that, you need to have water, or you have to need a special installation, a cooling installation outside. You need to have additional pipes in your tunnel to bring the water. In Europe, we said the maximal working temperature is between 28 grads and 32 grads. After, there is safety risk for the people. There really safety risk for the people. You can have accident for the people. I think here perhaps the people can work with hot temperature, but normally that's the standard. 28 grads is the standard. Another things to manage is the concreting. For concreting, you say you should have formworks. That's standard. You have to install before the ceiling, the drainage and the ceiling. The problem of the drainage and the ceiling is the risk of brand. That's one of the problems we have. So, but the rate is normally given by the concreting. So the ceiling should be performed in advance. And you have to have one workshop for the installation of the drainage and the ceiling, and one workshop for the concreting. But the problem you have, it's long distance and high temperature. It should be taken in account. The temperature should be taken in account for the production, transportation, and placement and hardening of the concrete. It takes a lot of time to transport the concrete from the batching plant to the front or to the casting place. So the contractor and the client have to study that in advance. If you want to have good concrete, you have to manage the hardening, the transport of your concrete. And sometimes you have concrete, it takes more than hours to transport the concrete on site. And sometimes it is better to install your batching plant in the tunnel, in a cavern in the tunnel, than outside. And if you have a very long tunnel, it is wise to use not only one formwork, but several. And you can have primary and secondary formworks. And we said that it's called in English the backstep method, with primary and secondary control. For example, at the Lötschberg, we have six formwork, and we perform 1,000 meter concreting per month with that. And now we have very good recipe of self-compacting concrete, and it will be very interesting to use self-compacting concrete for the quality or of the final quality of the work, and also for the worker, because you have no vibration noise of the concrete. And the last thing to prepare is the reuse of excavated material. Professor Galler is one of the specialists. He's leading a group on that in Europe. And if you are doing a project, you have to think how I will get my granulate. And one of the standards is to reuse the excavations material. So you can crush the good material you had to prepare your concreting, your concrete granulates. And it's often very economical to produce that on site. But you can see here that's a picture of the Lötschberg. It takes a lot of place. And you should, at the beginning of the project, the client should should prepare, study the concreting process, should study the preparation of the granulate. And you have to, it's an interaction between crushing and concrete. So you have to manage the interaction between the two systems. So you have to try to crush your material and perform concrete and to do concrete with this material and adapt your concrete recipe to the production of material. And that's a very, very important contractual point, because the client is normally the owner of the materials, and he delivers materials to the contractor to do the concrete. And we had very often the problem in Europe that when the concrete is not good, the contractor said and claim it's the materials. If you want to avoid some problem, you have to study that in advance, for example, with lawyers. Okay. And the management of the muck have to be planned also in advance. So not all the material you will find is good. So you have to study in advance when is the good material coming and where I can stock this material. You have to ask, I have enough material or not. You have to plan all the muck management and the production of concrete granulate in advance. And you have to adapt the concrete mix design to the granulate production. If you product too much fine material, fine sand, you will be, at the end of the project, you will have a huge amount of sand which is not used. So if you have to adapt the recipe, the mix design of your concrete to the production, it's really not easy. Yeah? And you have to follow the production, and you have people who have to control that the production is adapted to the demand. It's not so easy, and it takes time, and it should be revised very often during the project. It's very important to have some specialists who know these problems, because you have to choose the good crusher, because the primary crusher should keep the maximum size of the material. So you have to adapt the crushing to your transportation equipment. If you are transporting with band conveyors, and if you are transporting with trucks, you don't have to have a primary crusher in the tunnel. And after that, you have to screen also all the fine elements, and to have to eliminate all the unsuitable materials like metallic pieces, wood, such things you can find in a tunnel, during excavation in a tunnel. And after, you have to have a very specialized crushing plant, which we will crush, screen, wash your material to produce the concrete aggregates. And the system has to be a little bit flexible in order to produce the best size of material related to geological change. It's really not simple, I have to say, but it has to be studied in advance. And you have to manage temporary and final deposit area according to your national regulation. It should be also planned in advance. Here you can see two provisory deposit. For example, this deposit was in the mountain, and afterward it was built. It was built out, and you need a lot of space. That was the picture I showed you. For example, here you have the portal, the access, really the installation for the tunnel. Here the camp, and here the rest of the place is the managing of the muck. But here it's very special because there is that was at the south part of the Lötschberg. The muck of 3 tunnel portals is coming here, one with band conveyor and the 2 others by train. And after that, we manage the material here. That's the stocks of good materials, and the bad materials, the quality we cannot be reused, were installed in final deposit. But It's you can compare, that's the installation for the tunnel, that's the camp, and the rest is for the muck management. I'm a little bit late. Okay, you have to manage the communication. I will speak about that after. You have to have two communication systems. You have to maintain all the communication. You have to maintain all the equipment, the water equipment. You have to manage eventually the ventilation, the gas, and I will speak that about on the other points this afternoon. You have to manage the illumination. Here there is rules. I don't know the legislation in Argentina. Here, if there is no legislation, you have in the ITER guidelines #1, you have some guidelines for ventilation. They say the working area 60 lux, access way is 10 lux. The problem is the moving parts. And you can, avoid accident. I don't will speak too much about accidents. There is this guideline of the ITA that's very important, the guideline 1. You can download it from the ITA site and read it because a lot of things are written in these ITA guidelines. What you should manage if you have inclined gallery are the brake of the trucks. You have to have special rules to manage the brake. You have to control very frequently the brake of the truck, and you have to give advice, you have to give order to the people. If you have an emergency with brakes, one truck has no brake, in a descending gallery, the driver should decide to go immediately on the wall with his trucks. If not, he will take a high speed and it will be very dangerous. So you have to plan that, you have to instruct people, go directly on the walls. You have to plan also in advance. Very often the client are neglecting this problem. You have to plan in advance the electromechanical installation of your tunnel. Very often the mistake of the client, they plan the civil part of the project and come afterwards with the electromechanical studies. And you have to be performed, you have to be done in parallel. And if you have a railway, long railway tunnel, the logistic is complex because the access for the construction, installation of the cable, of the equipment will be done by trains. So we will have a train schedule, and sometimes we have performed that at Lötschberg. We have prefabricated all electromechanical parts in containers, control, test all the system outside in a big industrial building, and after, when all was tested, we bring the container in caverns, so we save time with this solution. And the problem we have with the construction of electrical equipment, electromechanical equipment, the people are not workmen of tunnel, as there is a lot of people, a lot of company, and the safety is very difficult because these people are not used to work in tunnel. Okay, I'm sorry for the delay, 5 minutes. A key success of tunnel construction is the experience, I have to say. So we try to share experience in the ITI, so you can look for this group publication. There is 2 publications on long and deep tunnels. There is a lot of publication on safety. You can download this publication from the ITI worksite. And we have experience on the long tunnel, and I have to say the European engineers company have gained a lot of experience, so you can use also expert. If you have a picture, it's a visit on the Tunelería tunnel with people of working group 17, working group 2, and we try to share experience. Gracias por la atención.